Let's graph this parabola. Y equals the quantity x plus 2 squared minus 3. First thing you want to realize is that this is actually in its graphing form. Y equals a times x minus h quantity squared plus k, where a is actually equal to 1, and that is actually positive. 1 is greater than 0. That means your parabola is going to be a U shape opening up. Now, we also know the vertex. The vertex is one of the most important ordered pairs on the parabola. It is actually h comma k. So for this particular example, the vertex h comma k is actually equal to -2 comma -3. Now we're going to need to graph 2 more points on the left of that ordered pair and then 2 more points on the right of that ordered pair. So if you think about it, we could organize our ordered pairs in a t-chart. Let's say x here, y here. We need 2 ordered pairs to the left of it. So why don't we try -4 and -3? We already have -2 comma -3. And then why don't we try -1 and then 0. 0 is going to be really key. So when x is 0, can we find can we find y? When x is 0, we can see that 4 minus 3 gets you 1. So we do know 1 here. We get a 1. When x is -4, we also get a 1. Right? Because the quantity -2, right? When x is equal to -4, we get y is equal to -4 plus 2 quantity squared minus 3. And then what is this? This is equal to parentheses -2 squared, which is +4 minus 3. So that will get you 1. Continue in this fashion. You get all the ordered pairs. Put in x equals -3 and then evaluate for y. So we get -2. And here we also get -2. Let's go ahead and plot those ordered pairs. Whenever you're graphing in an algebra class, make sure you use your own paper, your own pencil, and really draw the graph yourself. Okay, labeling. You definitely want to label. Graph paper certainly helps, and if you have a straight edge, that helps as well. Let's graph all these ordered pairs. Let's first graph the vertex. The vertex is really key. Graph the vertex first, -2, -3. And it's right there. And we know that this is going to open up. So -3, -2, -1, and then -2, and 0, 1. Nice shape here. Pretty standard parabola shape here. And then, of course, -4, 1. Yeah. And then notice you play connect the dots. And so this parabola emphasizes that there is a minimum for this polynomial. There's actually a minimum value for this polynomial, and that minimum value is actually -3. Okay, so that's really the emphasis of a parabola. It usually expresses a maximum or a minimum. For a parabola opening up, this one is going to express the minimum value, which is -3. Well, we've graphed it, so let's circle your final answer. Make sure you put arrows at the end of your parabola. That's really important because you're going to be asked to match the domain and range of this quadratic function. So make sure you put arrows. Let's circle our final answer. Our final answer is the graph. And of course, it's labeling as well. So let's circle all those ordered pairs. Let's go ahead and graph this parabola. And a parabola of this form is actually a function. So instead of saying y, I'm going to go ahead and bring back function notation. This is of the form f of x is equal to a times the quantity x minus h squared plus k. And remember that the vertex is being represented by parentheses h comma k. The thing that we have to do here is actually complete the square. If we complete the square, we could make this look like it in its graphing form where we could identify the vertex. So why don't we do that? First, rename y to be f of x is now equal to, I'm going to focus on x squared minus 10x, and I'm going to leave a space there. We'll put a gap here. I'm going to put plus 22 here, but we're going to complete the square right here on the x squared minus 10x. So remember, how do we complete the square on, let's say, x squared plus beta times x? Well, you take your beta divided by 2, and then we want to add beta over 2 squared. And that will help you complete the square, and it will allow you to factor a perfect square trinomial. So our beta is actually 10. Take 10, divide by 2, you actually get 5. Take 5 and square it, we get 25. So add 25. I should mention that it doesn't matter if it's plus beta x or minus beta x. It could be minus beta x also, and you would still add beta over 2 quantity squared to complete the square. Okay, so the first thing is take beta over 2, and then the second thing is take beta over 2 and square it. All right. Once again, take 10 divided by 2, you get 5, square it. We're going to go ahead and add 25 here. Now, that's illegal because we need to make sure it's equivalent to the previous expression over here. So we can't just add 25 to this expression. Instead, what we're going to do is add 0. And how do we add 0? Well, now we're going to take away 25. Because if you add a 25 minus 25, you just added 0. So now we're in great shape. Let's rewrite this. F of x is now equal to the quantity x minus 5 squared. That's exactly why we complete the square. Minus 3. Now we could identify the vertex. And the vertex is really key. It's going to be parentheses 5, negative 3. So the vertex is actually in the 4th quadrant. Now we need to graph 2 ordered pairs to the right and to the left of this. So why don't we make a t-chart and start labeling those ordered pairs? Let's say x here and f of x here. Let's try 3, 4, right? Then 5, we already know the output for 5. The output for 5 is negative 3. And then why don't we try 6 and 7? And then, of course, all you're doing here is evaluating. You could go back to this function here and evaluate, f of 3. I'll do one of these, and then so that you get the hang of it. F of 3 is going to be what? F of 3 is going to be quantity 3 minus 5 squared minus 3. So that's negative 2 squared, which is 4, minus 3, which equals 1. So that gives you 1. And if you do 4, well, we get positive 1 minus 3, so we get negative 2. And if you do 6, we get negative 2. And if you do 7, we get 4 minus 3, which is 1. So let's plot all those ordered pairs. Let's graph the vertex first. So I'm going to put another quadruple star there because I'm going to graph the vertex first. That's really, really important. 5, negative 3. 1, 2, 3, 4, 5. And if you have graph paper, make sure you use it. Graph paper is going to help you. Always draw your own graphs and label your own graphs. That's really important as well. It helps you better understand domain and range. So don't use some kind of electronic device. If you want to learn algebra, draw your own graphs. Drawing is a mathematical skill. 1, 2, 3, 4, negative 2. Aha. And then, of course, we have 6, negative 2. And then we have 7, 1. And then we have, 3, 1? Yeah, and then we play connect the dots. Draw a U shape opening up. Make sure you put arrows at the end because you do want to match the domain and range of this function as well. Let's circle the graph. And let's circle your labels. And I put my labels in a t-chart. Let's graph this parabola. It says y equals negative 2x squared minus 12x minus 17. First thing we want to do is put it in graphing form. And a parabola of this type is actually a function. So I'm going to use f of x instead. I'm going to go ahead and use function notation. F of x is equal to a times the quantity x minus h squared plus k. Where your vertex is what? Vertex is parentheses h comma k. It's that ordered pair h comma k. Now if a is negative, it turns out the parabola is actually opening down. So why don't we put our parabola in this form? So let's replace y with f of x. And then we're going to go ahead and complete the square. So I want to factor out a negative 2. And let's see what's left. We have a x squared plus 6x. And then we leave a space. I'm going to put parentheses here. I'm going to take the minus 17 outside the parentheses. Now the trick here is to add 0 to the right-hand side of this equation. So how do we add 0? Well, we do this by completing the square here. Take 6, divide by 2, you get 3. Square it. We're going to supposedly put a plus 9 inside, but you got to be very careful here. If we put a plus 9 here, that really says subtract 18. So all of a sudden I've subtracted 18 on the right side of the equation. Now I'm going to balance it out. I'm going to add 18 back. So if you subtract 18 and add 18, you really added 0. Let's rewrite this f of x. F of x is now equal to negative 2 times the quantity x plus 3 squared. That's exactly why we completed the square. And then we have plus 1. You can see that a is actually equal to negative 2, so this certainly will open down. Now let's get some ordered pairs here. Let's get 5 ordered pairs, and let's identify the vertex. The vertex is actually negative 3, comma 1. And of course, we need 2 ordered pairs left of that. So why don't we try negative 5 and negative 4? Let's find f of negative 5. F of negative 5 is negative 2 times negative 2 quantity squared plus 1. Remember, do order of operations. Do exponents first. So that's negative 2 times 4 plus 1. So that is negative 7. So we have negative 5, negative 7. And then if you do negative 4, you'll get an output. So find f of negative 4. If you need to, pause the video and do it yourself. You should get negative 1. Then why don't we try negative 2 and negative 1 as well. You get negative 1. And we get negative 7. Alright. If you have graph paper, use it. If you have a straight edge, use it. A straight edge could be just the side of your book or the side of your binder or the side of your calculator. If you got a straight edge, go ahead and use it. Take advantage of it. If you have graph paper, take advantage of it. Make sure you draw your own graph. Drawing is a mathematical skill. It will also help you better understand domain and range. Okay. So let's plot the vertex first. Negative 3, 1. Negative 3, 1 is right here. And let's go negative 4. Negative 4, negative 1 is right here. And then negative 3, negative 1. And then we got negative 2. I'm sorry. I said negative 3, 1. Oh yeah, negative 2, negative 1. And then negative 1, negative 7. 1, 2, 3, 4, 5, 6, 7. Right here. And then over here, there's another ordered pair. There. Play connect the dots. And then connect the dots here. Probably a little bit more rounded here. A little bit more rounded there. And there you go. You have your graph. Make sure you have a vertex. This parabola emphasizes that there is a maximum value, and that maximum value is actually a y value. The maximum value for this parabola is positive 1. Let's go ahead and circle our final answer. Circle your graph and circle your ordered pairs. Just for bonus information here, every parabola has a mirror, and that mirror is called the axis of symmetry. The axis of symmetry is actually a vertical line that goes through the vertex. And the way we write the equation of a vertical line is simply write x equals negative 3. X is always negative 3. So remember, the axis of symmetry is actually a vertical line that is written as x equals negative 3. So why don't we label it there? Finding the x-intercepts in the vertex of a parabola. Here's a parabola, y equals x squared plus 2x minus 8. A parabola of this form is actually a function. I'm going to go ahead and use function notation. F of x is equal to x squared plus 2x minus 8. In order to get the vertex, the best form we could write it in is actually a times the quantity x minus h squared plus k. In order to do that, we need to complete the square. We're going to complete the square on the first two terms. In other words, x squared plus 2x. Remember, how do we complete the square? We look at the beta and we divide it by 2. Look at this beta here. Take beta divided by 2, and we complete the square by adding this expression over here, beta over 2 squared. So that's what we're going to do. Take this 2, divide by 2, we get 1, and we're going to take 1 and square it. Well, 1 squared is still 1, so we're going to add 1 here. Then we're going to take away 8. And we got to realize we can't just add 1 to the right-hand side of the expression. So instead, we're going to add 0. So how do we add 0? We take the 1 off like that. But let's write minus 1 again. There. That looks pretty. Now we're going to take f of x. We're going to factor now. Factor the perfect square trinomial. You get x plus 1 quantity squared, and then minus 9. Now we can read the vertex. The vertex is the ordered pair, -1, comma, -9. We need to find the x-intercepts. Well, the x-intercepts occur when y is 0. So we're going to go back to this equation, and we got to make sure the output is 0. So 0 is over here, is now equal to the quantity x plus 1 squared minus 9. There's many ways to solve for x here. Just for variety here, why don't we pretend this is a difference of two squares? So then we will factor a plus b times the quantity a minus b. So that is a difference of two squares. Let's go ahead and factor. This is equal to x plus 1 plus 3 times the quantity x plus 1 minus 3. And that isn't so bad. So x plus 4 equals 0, or x minus 2 equals 0. So x equals -4, or x equals 2. X-intercepts are -4 and 2. Translated as ordered pairs, another way of writing the answer is actually -4, comma 0, and what? 2, comma 0. So sometimes you will be asked to translate the x-intercept as an ordered pair. So make sure you read the directions very, very carefully. Either one of these are acceptable, but just make sure you're following directions. Another thing you could find is actually the axis of symmetry. Remember, the axis of symmetry is a vertical line that goes through the vertex. So if you look at the first half of the ordered pair of the vertex, you're going to realize x is -1. And the way we write vertical lines is actually through an equation. And that equation is x equals -1. Remember, that is a vertical line. So the axis of symmetry is a vertical line and is written as x equals -1. You can see why you would write the x-intercepts in English. Notice I don't use the equal sign here. I actually have to spell out the word r, A-R-E, r -4 and 2. Whereas the axis of symmetry is always written as an equation, x equals -1. Answer the following questions below about the quadratic function. F of x is equal to -3 times x squared plus 12x minus 13. There are three questions here. Does the function have a minimum or maximum value? And how can we tell? So part A. How do we answer part A? The best thing to do is to write this in a graphing form of a parabola. So we're going to write f of x is equal to a times the quantity x minus h squared plus k, where the vertex tells you a lot of information. It tells you when the maximum or minimum occurs. It It also tells you what the maximum or minimum is. And the vertex is, parentheses, h comma k. The coefficient of a, or the coefficient of x squared, tells you whether this parabola has a maximum or minimum. So if a is greater than 0, then the parabola opens up, which emphasizes a minimum. So if it's concave up, you have a minimum. What if a is less than 0? Then your parabola is concave down. If a is less than 0, your parabola is concave down. And that means you have a maximum. You have a maximum y value. Well, in our case, why don't we get it into its graphing form? If we get it into its graphing form, we could definitely answer the question. F of x is equal to negative 3 times x squared minus 4x. Let's leave a space there. Let's subtract 13 out here. And we're going to go ahead and add 0 to the right-hand side of the equation. We're going to complete the square. If you complete the square, you subtracted 12. You subtracted 12. How can you see that you subtracted 12? You got to distribute that negative 3. So if you subtracted 12 all of a sudden, we need to add 0. So we're going to add 12 back. Now, we're going to take this f of x and rewrite this equation. Negative 3, x minus 2 quantity squared, subtract 1. Because a is negative, a is equal to negative 3, which is negative, this has a maximum value, right? This is going to have a maximum y value. This function has a maximum value because a equals negative 3 is greater than 0. I'm going to circle this sentence. Where does this minimum or maximum value occur? Well, we could read that from the vertex. The vertex is what? The vertex is, parentheses, 2 comma negative 1. The max value, the maximum value occurs at x equals 2. Or you could say the maximum value occurs when x is 2. So where and when is often interchangeable for this question. What is the function's minimum or maximum value? The maximum value for this function, f of x, is negative 1. Once again, all you have to do is read that negative 1 from the vertex. I could put a double-sided arrow here. There it is. A ball is thrown vertically upward. After t seconds, its height, h, in feet, is given by the function h of t is equal to 80 times t minus 16t squared. After how long will it reach its maximum height? Notice that when t equals 0, the height is 0. So in some ways, the height here, if you had to draw a really, really rough sketch, here's t, and then here's the output called h of t, which is in feet, the height in feet. So it seems like it's doing something like this. And it's dotted down here, and it's dotted down here. We want to find the time. We want to find how long does it take to reach its maximum height. So if we take this vertex and we drop it down, we're trying to find this right here. We're trying to find some t value that lies on the t-axis. So we'll make a note of that. We're really finding time. The way we're going to do this is actually by completing the square to find its vertex. Our goal is to get h of t into this form. A times t minus h, quantity squared, plus k. If we can get it in that form, we're in good shape. So instead of calling this t, why don't we call this h? Because that's what you're used to calling it. Let's find its h value, which is just the t value of the vertex, or the x value of the vertex. But in this case, x is t. All right, let's do that. H of t is equal to negative 16. And let's see what's left. We have a t squared minus 5 times t. Yeah. Let's go ahead and complete the square. So take that 5 divided by 2, you get 5 halves. Take that 5 divided by 2, you get 5 halves. Now square it. We get 25/4. Be careful here though. We need to balance the right side of this equation by adding 0. So if we really subtracted that amount, we really subtracted how much? We really subtracted 100. So we're going to add 100 back. Right there. Now h of t is the correct function. H of t is now equal to negative 16. We're going to factor t minus 5 halves, quantity squared, and then add 100. We'll go ahead and read the vertex. The vertex is 5 halves and then comma 100. We need to answer the question, how long will it take to reach its maximum height? So h is 5 halves. We have answered the question. Make sure you put the units though. So why don't we answer this in a complete sentence? After 2 1/2 seconds, the ball reaches its maximum height. Now it turns out the maximum height here is 100 feet, but it doesn't say we need to mention that. So it just says we need to mention the 2 1/2 seconds. And there's the final answer. Make sure you could show your work. Make sure you could show the process of completing the square. We're going to attempt part B in a very similar fashion. This is a different ball in part B. A ball is thrown vertically upward. After t seconds, its height, h in feet, is given by this function. What is the maximum height that the ball will reach? Once again, we're going to go ahead and complete the square. H of t is equal to negative 16 and we have t squared. We need a positive 68. So why don't we try 68 over 16t? Put in parentheses. Well, let's rewrite this to be a little bit simpler. H of t is equal to negative 16. We could reduce the fraction t squared minus 17 over 4 t. And once again, you leave a space to complete the square. Divide 17 over 4 by 2. We get 17/8. So to complete the square, we're going to take 17 squared here and 8 squared. And of course, 8 squared is 64. We need to balance this right-hand side by adding 0. Right now, we subtracted a lot. So we need to add back a certain amount to keep this balance. I'm going to add back how much? Add back 17 squared over 16 over 64, that's 1/4, so that denominator is now 4. Awesome. Now it's balanced. Let's rewrite h of t. H of t is now equal to negative 16 times the quantity t minus 17 over 8 squared. And then what's 17 squared? 17 squared. That's 289 plus 289 divided by 4. What is the maximum height that the ball will reach? Once again, we're going to read the vertex. The vertex is 17 over 8, comma, 289 over 4. Now we're going to extract the information from the vertex and answer the question. I am going to do 289 over 4 really quick. So that's 72 and 1/4. All right. The maximum height of the ball will reach 72 and 1/4 feet. Make sure you indicate the units. The best way to answer a word problem is to use words and units. So if you see a problem in sentences, then you would answer it in complete sentences. Or in this case, one sentence is enough. Make sure you remember to put the units. A vehicle factory manufactures cars. The unit cost, C, the cost in dollars to make each car, depends on the number of cars made. If X cars are made, then the unit cost is given by the function C of X. How many cars must be made to minimize the unit cost? Notice the function here is quadratic, and our goal is now write this in a form where we could recognize the vertex. Let's get it in a graphing form, and we're going to try to get it in C of X is equal to A times the quantity x minus h squared plus k, where the vertex is what? The vertex is h comma k. That is going to be really key. Let's start beginning this problem by completing the square. C of x is equal to the factor 3/10. And let's see what's left. We have x squared. We need to make sure we get 96. So why don't we have minus 96 over 3/10 times x. And we leave a space. And then we're going to leave that plus 20,355. Let's simplify a little bit. C of x is equal to 3/10 times x squared. What do we have there? That looks like 960 divided by 3, which is a nice number. That's actually 320 minus 320 times x. Leave a space. We'd leave that space there so that we could complete the square. Take 320 divided by 2. We get 160. Square it. And we get this number, plus 25600. Now be careful. We didn't really add that much. We added only a fraction of it. So we're going to balance this by subtracting that certain amount. What do we have to subtract? We're going to subtract 3/10 of it, right? 3/10 of 25600. Now we're going to simplify. We have c of x is now equal to 3/10. We can factor this. This is x minus 160 raised to the exponent of 2. Don't forget your parentheses. And we need to simplify this amount over here. This amount over here, with the aid of a calculator, we get plus 12675. Why don't we answer the question? How many cars must be made to minimize the unit cost? Is this going to be a function, a quadratic function with a minimum value? It is, because 3/10 is positive. So this is starting to make sense. 3/10 is your a value, which is positive. So we do know that this parabola is concave up. And if it's concave up, its emphasis is a minimum value. Now we know x is the number of cars. And so if you read the vertex, it tells you all the kinds of information. The vertex is 160 cars, and the minimum cost is actually $12,675. $12,675. But let's answer the question. It takes 160 cars to be made to minimize the unit cost. Don't forget your units. That's very, very important in science and mathematics. So when you're answering a word problem that is made up of sentences, you should answer it back with a sentence or two. I'm going to go ahead and find a range of a quadratic function. There's going to be a couple of examples here. There's a part A and a part B. And in part A, we're given a g of x. So we want to find the range of g of x. Now you got to remember, the range is actually the set of all output values. Okay, or the set of all outputs. In this case, remember the outputs are the y values. For part A, they are the g of x values. We're going to find this by completing the square and finding the vertex. So let's find the vertex. What we're trying to do is get g of x in this form, a times the quantity x minus h squared plus k. That involves completing the square. g of x is equal to x squared minus 8x. I'm going to put the plus 12 a little bit farther out. I'm going to go ahead and complete the square here with this x squared minus 8x. Take the number 8 divided by 2, you get 4. Add 16 here. But we're really not going to add 16. We're going to add 0. So we're going to add 16 and then subtract 16. Now we change the look of this function, x minus 4 quantity squared, and then plus 12 minus 16 is simply subtract 4. Because this is a parabola going up, how do I know this is going up? A here is 1, which is positive. This parabola is going up. So there's a minimum y value, and then the rest has to go higher than that, because that's the minimum. So if I wrote this in interval notation, I would write a bracket on the y-axis and point an arrow going like this, right? And of course, shade everything in between. Now, we already know what that minimum value is. It's actually negative 4. So this is going to go from negative 4 to infinity. That is not an 8. That's actually the infinity symbol. Except I wrote it the wrong way. I wrote negative 4 the wrong way. So let me change this. My negative 4 is written the wrong way. My negative 4 should have been written this way. Like that. The vertex, if you're wondering, the vertex is actually parentheses 4, comma, negative 4. And this negative 4 here is matching to that one. We need to write the range in interval notation. So the range in interval notation is bracket negative 4 all the way up to infinity. And then we could close that infinity, put a open parentheses on that infinity. Remember, infinity is a concept. It is not a number. Or you could say it's a symbol, but it's definitely not a number. Go ahead and try to do part B on your own. Remember, for part B, you're completing the square. You could pause the video and then unpause it to check your answer. When you're completing the square here, you take the 6 divided by 2, which you get 3, and then you square it. So you end up subtracting 27 at first by doing that. So you want to balance it by adding 27 back. You actually subtracted 27 first. Let's simplify f of x. F of x is now the function negative 3, x plus 3 quantity squared minus 2. This time, the parabola is actually pointing down. This time the a value is negative 3, which is less than 0. So your parabola is actually concave down, and if it's concave down, then you have a maximum value. So if you're reading these values along the y-axis, you would actually have an arrow starting way down there, and then you shade all the way up to the maximum value. And we just need to find that maximum value. That maximum value is negative 2. So there's the negative infinity symbol. You might need to rotate your head 90 degrees to your left. And then over here is just negative 2 is right there. Once again, there's the negative infinity symbol. So what is the range? What is the set of all outputs for f of x? We're going to write the interval notation, parentheses, negative infinity, comma, up to negative 2. We include negative 2 by writing a bracket. Ah, gorgeous. And so there's the range of f of x. You'll see me write things like this as well. I would actually write the range of g is equal to negative 4 to infinity. That's another way of writing it. That's a little bit more descriptive. Over here, this would be what? The range of f is equal to negative infinity up to negative 2 with a bracket. Once again, that notation is very descriptive. That's an advanced notation that I use. Feel free to use it.